Okay, there's a class next door, and you might hear some of the noise from over there flooding into this room. I apologize for that, but there's nothing I can do about it. So here goes. So the average, make sure as calculus students, you are clear whether we're dealing with when you're asked for average rate of change versus instantaneous rate of change. Average rate of change is given by effectively the slope formula. And instantaneous rate of change is given by the derivative. So the average rate of change here would be, the first thing we would do is f of 12. That's 13 times 12 squared plus 17. In the interest of space, I am going to skip some steps. 144 times 13, 18, 72 plus 17 is 1889. Okay? F of negative 4 is 13 times negative 4 squared plus 17. That's 16. 16 times 13 is 208. Plus 17 is 225. So that's going to be 1889 minus 225 over, it's going to be f of the latter minus f of the first over 12 minus negative 4. All right. 1889 minus 225, 1664 over 16, 104. That's the average rate of change. This one, find the instantaneous rate of change for f of x equals 13x squared plus 17 at x equals 8. Do. F prime of x is 13, and the derivative of x squared would be 2x to the first, because you bring the coefficient to the front, and you take the power down 1, and then the derivative of the constant is 0. So f prime of x is 26x. So the instantaneous rate of change for x equals 8 is f prime of 8 equals 26 times 8, which is 208. All right? Let me explain to you what the graph looks like. The graph of this looks like this. So if this is negative 4, this would be 12. So as you can see, it actually drops. It's actually dropping at the beginning and working its way back up. Okay? But that's the average rate of change. Okay? Again, the vertical scale is not necessarily to scale. This is A, and here's B. So this represents the situation at A, this represents the situation at B. All right.